Salam and a very good day to all. I am Wan Azhani Wamsamsudin from Computational System Intelligence Research Group, University Malaysia Pahang. Okay, today I would like to share with you a research from my group titled Zebrafish Larvae Locomotor Activity Detection using Convolutional Neural Network or CNN. Okay, these are the contents for my sharing today. Okay, first, we will look into the introduction of the zebrafish larva and also the convolutional neural network or CNN. And then we will move to the research overview on the neurotoxicity and behavioral assessment. Okay, then we will summarize the related problems together with the objective of the research work. And lastly, the proposed methodology will be presented and we will see the result for both normal and abnormal detection. Okay, first we go through the introduction of the zebrafish larva. Okay, zebrafish is a freshwater fish which is also known as Danio rerio. It is a popular aquarium fish, frequently sold under the trade name Zebra Danio. It is an important and widely used vertebrate model organism in scientific research, for example in drug development and also in a particular preclinical development. Okay, as a model biological system, the zebrafish possesses numerous advantages for the scientists. Its genome has been fully sequenced and it has well understood, easily observable, and testable developmental behaviors. Okay, recently, the researchers also used also used the zebrafish as a model organism in behavioral neuroscience to study the effects of the neurotoxin to the child development. According to the studies, human behavior will change when they are exposed to the neurotoxin. So the same reaction happens to the zebrafish larva when it is exposed to any chemical or neurotoxin. So zebrafish larva behavior can be a great indicator in behavioral neuroscience experiment. Okay, next, we do the introduction for the CNN or Convolutional Neural Network. Okay, in deep learning, a convolutional neural network or CNN, or also can be called as CONVNet, is a class of artificial neural network ANN, and it is most commonly applied to analyze the visual imagery. Convolutional networks were inspired by biological process which consists of an input layer, hidden layers, and also the output layer. The connectivity pattern between neurons resemble the organization of the animal visual cortex. There are many types of architecture based on CNN, but here we are using SSD MobileNet V2 FPN Lite. In this model, we have a base network, which is the mobile V2, a detection network, SSD or single shot detector, and a feature extractor called FPN Lite. Okay, next we jump to the research overview of this project. Neurotoxicity is a form of toxicity that can alter the normal activity of the nervous system in such a way that can cause permanent or reversible damage to the nervous tissue of the mammalian behavior. For this project, zebrafish larva will be used as the model organism in order to achieve the research objective. Previously, the behavioral assessment of the animal model is done manually using the human vision, but this method may lead to the misclassification error for the observer during the assessment stage. Besides, the monitoring and observing by human vision is tedious work and it needs to monitor and classify hundreds to thousands of zebrafish behavior in a certain period given. Hence, the automated detection system seems to be a much preferable tool, and this research aims to detect the locomotor activity of zebrafish larvae using the CNN method. Okay, here I listed three problems to be solved. The first one is the method of using human vision for the behavioral assessment is considered laborious, and the interpretation of the parameters observed can be differ between the observers. Okay, second, the method also leads to misclassification error for the observer during the evaluation point. And the last one is the manual monitoring and observing hundreds to thousands of zebrafish behavior through human vision is a tedious work. Okay, reflected to the problem statement given. Okay, the first objective for this project is to develop an algorithm for locomotor activity detection of zebrafish larvae using CNN. Okay, second is to validate the proposed algorithm on the detection of zebrafish locomotor activity. And the third one is to develop an automated system to replace the conventional method. Okay, next is the methodology. The methodology can be divided into two phases. The first is the preparation before the training. In this phase, the local machine is set up, while the Google Colab also will be set up. And then the second phase is the training and testing, including the validation of the proposed algorithm. Okay, first, we will look the local machine setup. Okay, this is the flowchart for the local machine setup. The process is started with the local machine setup and also the Google Colab setup. Okay, software TensorFlow version 1.5b will be installed in both machines. And next, the TensorFlow Object Detection API will be installed on Cloud Machine, and Cloud Machine will be setting up. And lastly, the Cloud Machine is tested whether it is working or not. Okay, this is the training and testing phase flowchart. Okay, the training and testing phase is started with the gathering training data. The video will be extracted into frames and will be resized using the Python scripts. Okay, next, the resized image will be labeled using label image software, which then produce the label map for the training purpose. The model is trained after the image and the TF record file have been uploaded to Google Drive, and the output inference graphs will be exported to frozen graph. The train folder will then download it to local machine, and the result can be checked using the TensorBoard. This is the result for the normal detection for the zebrafish larva behavior. Okay, graph in the left side show the learning rate graph, while the figure in the right side show the normal detection of the zebrafish larva in a petri dish. So from the result stated here, the classification error is about 0.3972 and the total loss is about 0.9543. The learning rate, batch size, the training step are related to each other. The learning rate controls how quickly the model is adapt to the problem and is referred to as the number of the training example utilized in one iteration. The smaller the learning rate and batch size, the higher the training step is required to train the perfect detector. The hyperparameter for this project is 0.015 for the learning rate and 4K training steps. Okay, so this is the result for the classification loss, localization loss, normalized total loss, regularization, and also the total loss for the normal detection. Okay, next is the result for the abnormal detection. Okay, the graph in the left side shows the learning rate graph. Okay, while the figures at the bottom of the slides shows the abnormal detection for the zebrafish larva. And the classification error for this abnormal detection is about 0.3197 and the total loss is about 0.71694. Okay, there are two important graphs which are the classification loss and the localization loss for the model. Classification losses are the losses for the classification of detected objects into various classes. Losses are the loss of the boundary box. Both localization and the classification can reach the lowest losses and keep in a straight line in 4K training steps. As a conclusion, the object detection model is created by using CNN architecture, which is based on SST MobileNet V2 FP Lite. This algorithm can detect two classes, which is normal and abnormal, with a higher accuracy and faster detection speed on machine. And the total losses of the training process is only between 1% to 2%. So for the future works, we have to increase the number of data sets in order to improve the accuracy and also reduce the classification losses. So that's all for me. Thank you.